Most D-block metal compounds are colored in their solid or liquid states. Color is associated with the ability of a compound to promote an electron from one energy level to a higher energy level. In the case of transition metal ions, under the influence of ligands, the degeneracy of the 5d orbitals is lost, and they separate into two distinct energy levels. One set, known as the Eg set, consists of two orbitals, dx square minus y square and dz square. The other set, known as T2g, when white light is incident on a transition metal ion, the electron in the lower energy d orbital set absorbs certain radiations and gets promoted. The transmitted radiation devoid of the absorbed radiations is the complementary color of the adsorbed light. This complementary color, for example, hydrated Cu2 plus ions absorb radiation of wavelengths corresponding to red light and transmits its complementary color blue. The colors of some hydrated ions of the 3D series of elements are given. Now, let us look at the magnetic properties of D-block. Substances, depending on their behavior in an external magnetic field, are classified into paramagnetic and substances that are weakly attracted to a magnetic field are called paramagnetic substances, while substances that are repelled are called. Paramagnetic behavior is caused by the presence of unpaired electrons in the atom, ion, or molecule. Diamagnetic behavior is caused by the absence of unpaired electrons. Every unpaired electron is regarded as a micromagnet with a certain value of magnetic moment. The magnetic moment of the electron is due to spin angular momentum. However, for 3D series of elements, the orbital angular momentum of the electrons is small, and hence, its contribution in these elements can be ignored. Therefore, the observed magnetic moment, the magnetic moment for these elements is determined by the spin-only formula. Mu is equal to square root of n multiplied by n plus 2. Here, n is the number of unpaired electrons and mu, when n is equal to 1 magnetic moment, is equal to 1.73 Bohr magnetons, and when n is equal to 2, we get 2. In case of iron, cobalt, and nickel, the unpaired electron spins are much pronounced. As a result, these elements are much more paramagnetic than the rest of the elements.